We are a pleasure to welcome Professor Jason Ward from North Carolina State University. Professor Ward works in agriculture and biological engineering with expertise connected to machinery, data, and digital technologies for agriculture. So it's a pleasure to have him with us today to share his perspective on machinery data and quality traceability. So Jason, the floor is yours.
Okay, I'm happy to pause if everybody needs to take a break for 10 minutes and start at half past. So totally your
Uh,
call. So
go ahead. I think that we can go ahead and then we will finish early.
okay, all right. Who doesn't love finishing early? Um, so hello, my name is Jason Ward. As you introduced me, thank you for that. I'm at NC State University in the U.S. and I do work a lot with how do we get value and multi-directional value from the data that we create on farms. And the system I want to talk to you about today is something that we've done with a full spectrum traceability solution for a crop that I don't know that many of you would have had experience with, which is cotton, which I do understand that there's some cotton growing in the south of Spain. It's a crop that I do tend to work a lot with, and it has some interesting in how we harvest and handle it. It creates some interesting opportunities for traceability that I think can create us a roadmap for how we can extend these ideas into other crops and other production systems. So and of course, I have to recognize that this work was sponsored by Cotton Incorporated. So there was called a checkoff program. So in the U.S., every single bale of cotton, and we'll get into those terms, the farmers contribute a few cents per bale, and Cotton Incorporated pulls that money together, and then they sponsor research and marketing programs. So let me start by introducing you to what is the modern cotton harvester in the U.S. Right? So it's a pretty complex machine. It can harvest 6 to 8 rows of standing cotton at any given time. Um, Price on this machine, depending on options, is about $1.2 million US. So it is a significant investment for a machine that probably runs less than 500 hours a year, right? So it's a has some challenges in the economics, but this is the technology that we have now. And basically, there's rotating spindles that extract the fiber from the standing plant, pulls them into the vertical ducts there you see on either side of the cab, collects them into the back of the machine. And all of that is very similar to all the previous cotton harvesters that have existed in the world, right? So spindle harvesting is old, pneumatic conveyance on the machine is old, and accumulating that into the basket is an old technology. What has happened most recently with this harvesting system is the development of what's called the round module that comes out the back of the machine. So essentially, what happens is there's basically a baler that sits on the back of this machine, and it creates a bale, or a module is the language that we use for it, of cotton. So it's about 8 feet in diameter, about 8 feet wide, so about 2.5 meters, right, in either direction. And that's about 6,000 pounds of cotton per module. So what is that? 2,700 kg somewhere. So
Yeah. Mhm.
yep. So it winds up being a a unique way that this crop is harvested and then packaged. And what's happened is now we have the ability to assign every single one of these modules a unique serial number. And that creates some huge opportunities to track from where in the field this crop originated all the way to the garment or the textile or wherever it was used, because we have this ability to create a unitized, individually identified package of this crop, right? But that's kind of where it starts. Now, the title is machine data, so let's get into how we leverage the machine data to pull all this together. So the most fundamental machine data that we get during harvest is yield, right? Cotton harvesting, much like many of the other types of crops, does have a yield monitoring system. It is a non-contact system in that it basically has a microwave emitter and receiver in the ducts between the header and the basket at the top. And so it basically uses reflection from that microwave sensor to correlate to mass flow rate through the machine, right? And so generally, most yield systems log data at a point per second interval, right? So whenever we capture the spatial location and write that mass flow data, we're doing that on a point per second basis. While historically, we have used yield maps to think about what they're called yield, right? And looking at the spatial relationships of this mass flow rate through a machine. What we also have is a very precise map of where that harvester was in space and time at a 1 second interval, right? So we have two different data types there that come together to make the yield map: time and position and the mass flow rate. Okay, so let's keep that in mind as we move forward. I also mentioned the word quality in the title. So let's get into what I mean by cotton quality. So this list here on the left are all the ways that we grade cotton fiber for quality, right? And on the right, across the other columns here, are what are the things that affect that quality. So the first thing I want you to recognize is that it's a complex system, right? Because the variety, the type of seed that was planted, where it was grown, the rainfall it received, and then ginning is the process where we remove the seeds and any non-fiber material from the cotton fiber, right? So it's the cleaning process. So all of these things are how quality is graded. So color grade, we want a bright white fiber so that people can then dye it whatever color they want it to be, right? Staple is what we define length of the fiber. Micronair is a measure of maturity, which is kind of like a diameter of the fiber. And then strength, how uniformly long the fiber is, uniformity. And then there's leaf and trash, which is biological material from the plant that got into that module when we were making it. And then EM is extraneous matter, which is all kind of non-biological material. Like if there was a piece of trash in the field that got harvested, right? So these are all the ways that we think about grade. So what we do is this is a warehouse where finished cotton bales are stored. Every single one of these bales are sampled and sent to a U.S. Department of Agriculture lab where they are graded, right? So these bales are about 500 pounds, right, of cotton. So what happens at the gin is the modules of the field harvested seed cotton gets cleaned and turned into these 500-pound bales that are then ready to go into the textile industry, okay? So if we kind of think about what that workflow would look like, in harvest, we would create a yield file, right? And it just kind of lives on its own. The farmer uses it to make agronomic decisions. In the gin, we convert the round modules into bales, right? So we take the raw product and turn it into the finished product, which then that finished product is a raw material for down the road. And then there's this grading step that happens. Well, like I said, that now we have the ability at this point, all these systems are all siloed, right? They're independent. They're not talking to each other very well, and there's not like a flow of information from one end to the other, right? Well, once we bring in this unique identifier here for every single one of these individual modules of harvested cotton, and again, if we're going to talk about machine data, let's look at the data flow that actually comes out from it. So on the machine is generated what's called a harvest ID file. And the only thing that's in that file is, on the left-hand side is the hex code that's read from an RFID tag that's in that plastic wrap, right? And then serial number, and we have the location where that module was wrapped. Okay, so fundamentally, when that module is wrapped, we're closing adding any more material to it. So that's the location and the date and time where it was done. Okay, so, and we have other information about grower, farm, field. So, so already there is a certain amount of traceability here. But if we wanted it to move on, we would have to either create a handwritten record or a new database file or something like that. So, but something happens here when we have this data. Because now, if I look at on the left what I get from the HID file, right? So the green dots are where every single one of those cotton modules were completed, right? Where it wrapped, okay? The red dots kind of on the top end of the field there are where it was dropped off the back of the machine. There's like a cradle that can carry the module to the edge of the field on the back of the machine. But if I just focus on the green dots where the modules were completed, and then using the yield map, not so much for yield, but as a high precision time and place map, what I can do is extract the individual field areas from which each one of those modules originated. So in each one of these colors is the area, the rows, the passes that contributed to that one module that got harvested and now has a unique identifier, right? So now we have basically a spatial basis for this module that now starts moving through the production system, right? And then if you look at the entire field, it gets a little bit hard to process, but this is what that entire field looked like. And each one of the colors is a unique module path, right? So where it was harvested from. So now what we have is, from the harvest, we get yield plus HID, which gives us the spatial basis for the module. And then we have a unique module serial number at the gin, which then creates a unique bale identifier whenever it's sampled and sent for quality grading, okay? So if I can cross the bridge at the gin to make sure I know precisely which module goes to which gin or which bale, then I have basically an entire traceability stream from field to end use, right? So to cross that bridge, and we're not going to hang out here too long, this is what's called a module unwrapper. It's a machine at the cotton gin whose job it is to pick up, pull the plastic off of that module, right? And while it's doing, before that plastic is removed, the three like square boxes here, those are RFID tag readers, right? So that plastic, that plastic wrap has RFID tags built into it. And so basically, if I know the order in which the modules go into the gin, I have a very good estimate for which bales came from which module, right? Because it's basically a continuous flow process, right? So there is a little bit of error, in the in that, but we do have a very good estimate of that. And I will say all that plastic is collected and recycled and then turned into plastic wrap again. So it's not as ecologically aware as I would like for it to be, but they're working on it. So now we've kind of crossed this bridge where we have this file that flows, that HID file moves to the gen, and then as it transfers, we have it all the way out to that quality grading piece. And that quality grading piece is important because that's where we put the financial value on that crop, right? I want to hang out here for a second and say in most systems, I would say this is true of the US. I don't know all the EU systems very well. The value leaves the system at this point and goes on to the manufacturer and the retailer, right? So at this point, there's no value flowing back to the farm field. But I would argue that we can create some value by understanding these quality grades that we can now look at for the first time on a spatial basis, right? So all those factors that we looked at, length, strength, uniformity, color, right? Trash content, leaf content, all of that we can now take back to a subfield level and see if there are growing practices, inputs, managements, things that we can do to maximize those quality factors. And hopefully then we're creating a good yield of a crop that has higher financial value because we've optimized our quality. Okay. So just let's kind of keep that in mind. So what we can do is create, this is a mean bale value per module map. So fundamentally what we're looking at here is how much money was made on a spatial basis in that field from that harvested crop, right? And that actually becomes kind of powerful when we think about it. The idea of profitability mapping or financial mapping really speaks to the bottom line. And the colors here aren't great, and I apologize for that. But you should see that there is a green stripe about here in the middle of the field where we see some greater financial returns, right? It's blended in with some other mid-range returns. And then towards the right-hand side of the field, we're lower down that range, not all the way in the red, right? And the color grade here is more green, more money, right? So we do kind of see this little stripe here in the middle where we have some increased returns. Now, let's look at that micronair value, right? That maturity number, that diameter of the fiber. To my view, there's a clear correlation where as the micronair was higher in this case, which again, maturity of the fiber was greater, there were greater returns where that happened, right? And then to the right, where we have lower micronair, is where we saw lower returns in that field. So if I was thinking about how to utilize this data, now that we can put these quality factors onto a spatial basis, as the farmer would start thinking, what did I do in this area of my field that maybe was different from somewhere else in my field that allowed that fiber maturity to increase, which created me greater value, right? Was there something I did? In this case, what we discovered was that that strip that's bright green, where the micronair is higher, that actually had an emergence issue in this field. And it was replanted later than the rest of the field, right? So, which was interesting because, there was a hurricane that year in North Carolina. And so the fiber that had been planted earlier was open and was exposed to all that adverse weather, whereas the crop that hadn't opened yet, which is what's in that green stripe, weathered that hurricane much better, and the crop was in much higher quality when that happened. So there's just one of those things, right? So we had a random event that created a strip of higher value crop. And then we can look at other things like linked uniformity. Okay, so again, um, I'm not going to claim causation here, but there's some correlation where we had higher higher fiber uniformity in the middle of that field where that replanted strip occurred, and we got greater returns, right? So I think that there's some, and this was the first time that we looked at this data from a few years ago. And whenever we realize that there is some kind of a spatial pattern to quality, right? And it's not just a random variable. It's not just lost in the sampling effects and everything else that happens. Okay, now we can manage for quality and not just yield, right? And that gets pretty exciting to me because that's how the price comes up, right? As you drive quality up. And so I can show you here another field, field R, which this is a grower's field that we were looking at. And this is interesting because this has a variety trial in it, which means that the farmer had planted strips of all different varieties of cotton in the field. So that allows us to kind of see if this idea returns. So again, we started with a financial basis. So that's the one I like to bring up first because that's what keeps us all farming, is the financials of it. And you can see that, and this is a different scale. This is in what's called points per pound. So basically, this would be a premium or a discount that's added to a base level. 1,000 points is a dollar in this system, right? So we do see a couple of red strips here along this one block where there was a discount, right? As I understand it, this area of the field is along a drainage ditch. And so there probably were some excess weeds in that area of the field that got picked up by the harvest, which made additional material that had to be cleaned. So it reduced the value of that crop, right? But we do kind of see there's some interesting patterns here where there are some strips of higher value or lower value. Now, especially if we look at this as it aligns to all the different varieties that were planted in that field, right? So, and the reason I haven't explicitly said this is the variety, this is how much it made, is that some of these were private companies doing variety trials. Some of them were public, variety trials. So I didn't want to get into the legals around some of those issues. But, we do kind of see that there are some areas here that could potentially match up to where we see some different varieties that got planted in that field, right? So this one aligning with that highest value that we saw in that field. And again, this is the yield map for that same field. And it's important to notice here, like one of the things we have to deal with when interpreting yield maps is what are environmental variables, right, which would affect multiple areas of the field, and what would be variety specific effect, right? So for example, this area, that cuts across multiple of our rows, that would indicate probably a drainage issue or something like that. So that's going to affect multiple of those different varieties. But if you notice, there are some places here where there's patterning to the yield along the rows, right? Which would indicate that's a row effect or a variety effect versus an environmental effect. So if we will look at, and again, like keep this one in mind, which is our returns, right? How much more or less we made from a base. Kind of keep some of this in mind of where the highs and lows are. Lows kind of to the far left side, basically darker green to the farther right side, right? So if we look at leaf content, so leaf content just means extra cleaning has to be done to get that fiber clean and ready to go to market. So the place on the left where we saw lower returns or where we see much increased leaf content, right? The place on the right where we have lower leaf content, we saw greater premiums for our product, right? So whatever happened in the leaf management prior to harvest, it didn't go as well on the left side of the field as the right. and that impacted our value. I also just want to show you this again, that we didn't just make that up in this one field. So these are two different fields where we have differing harvest dates and different leaf grades, right? So cotton will continue to grow. It's a tropical crop. It doesn't terminate itself. It'll just keep going. So if we did some leaf management, early, and then wound up harvesting late, or if we put our leaf management on and then had to harvest early and it didn't have time to be effective, there's all things that we can do. But what I want to really point out here is that there's a clear correlation between our harvest date and our leaf content. And just being able to see, not even on the financial basis, just to know that whatever we were doing to manage our leaf that was present on that crop before harvest, it had varying levels of success based on when we harvested that crop. So even before we put it in financial terms, there's a spatially aware quality interpretation here. The reason why I do get kind of excited about the financial mapping is that then what we can do is we can take what's called a partial budget. We have a Department of Ag Economics here at NC State, and every year they produce a budget for what it costs to grow a crop, right? And so we can basically simulate, in this case, if you used this production budget to grow your crop and had all these costs associated with it, and made the yields and the financial returns that we made from the data that we can see and the quality mapping that we did, we can actually create what's like a break-even map for that field. So basically, we can know on a spatial basis where you exceeded the cost of production and where you fell below the cost of production, right? And so that means that we can now, on a spatial basis, assess, did this field make any money? And again, we're down at that point per second level, right, which is a very fine spatial area that we're looking at this on. And so once we have the financial returns map, then we can put that into a profitability map if we have some idea of budget. Now, in this case, this was all simulated data with the financials. Yeah, I didn't ask the farmer to open his books to me and kind of show me what his total cost of production were, but it's just a kind of a thought exercise on what is possible with the data. Another thing I'll add is we can also improve operations at the gin, and that matters because how that gin operates has a direct influence on the quality, which is what the farmer is paid on, right? So for example, it's kind of a tough plot here, but let me walk you through it. This bottom blue line are the number of days that cotton module was in that wrap, okay? The top line is what's called plus B, which is a measurement of how yellow that fiber is, right? So as you would expect, if you have a biological product harvested from the field, wrapped in plastic, and sitting outside, you would imagine that you don't want it to stay in that condition for very long, right? You don't want it to stay wrapped in that field, right? So what we see is most of the time we're about 10 days to 2 weeks, right? Whenever that module has to sit in that wrap outside. But if you notice, if something happened and that time period went to 30 days, we see pretty clearly that it gets yellower, right? And if we are paid on how white the fiber is, the longer it sits in that plastic, the yellower it gets. So now how efficient, how quickly that processing step can happen has a direct value on farmer profitability. So it becomes pretty important to get that optimized and running well. And as you can imagine, this is the starting moisture content matters. And the first thing I want to show you here is that this is about 1,800 of those bales and their moisture content. It is very consistently about 8% moisture, right? Which is pretty much the target for that product, right? But we do have a few outliers here with higher moisture or lower moisture. If it gets too low, there's a fire risk. If it gets too high, again, we have a quality issue, right? So what we can say is that over time, and again, this is that plus B, which is that yellowness factor, there is a linear relationship between time, amount of days spent in wrap and how yellow that product gets. So it's a very clear relationship that we can negatively impact our fiber quality if we don't gin and process this product in a timely fashion. And so then how you run that processing step becomes very important. And to kind of get to some of that information, we have done things like we added moisture sensors to the system that they use to move the modules around at the cotton gin. So basically, these spears, they push into the module and pick it up, and then they move it wherever it needs to go. Well, we added some resistance-based moisture sensing here on all 4 of those spears, and we were basically able to align less than 2 points always, generally less than a point of moisture content difference between what was recorded at the harvest time and then what we measured with this spear moisture system in the field. And it's important to note that while we're doing that, if you see, we have these RFID antennas here. So now we're not just measuring the moisture, but we're creating a data record of this module that is already uniquely identified with a serial number from the field. And we are getting moisture content at different points in the system, right? So we can kind of pull all that together and identify trends and see if there's some management practices that we need to undertake. So next steps, what we're continuing to kind of pull these systems together. It's important to note that we didn't, outside of that moisture sensor on the spears that I just showed you, the entire rest of the system, we didn't create a single sensor. We didn't create any new data, really. What we did is found fundamental ways to kick down the walls between different isolated data systems and try to take the value that comes from that traceability back to the farmer and have it not just leave the system as it goes to manufacturing, processing, retail, right? So that's kind of something that's really important to us. So now we can, at scale, right? Before, you saw those variety trials, where you're planting, 8 rows wide by a field length long of a single variety, and then you're analyzing it to see what happens to it. Well, now if we know the planted variety of all the multiple thousands of acres that this farmer grows on, we can basically at scale check the performance of those varieties for quality factors, right? In their local context, on their ground, in their production system, right? And so that becomes, I think, incredibly valuable. Next, we want to continue to look at some of the things that we can do with the gin, since we've documented that gin processing has a direct impact on quality. So if we can optimize that, we're better off. And I think finally, now that we've kind of got these pipelines built and figured out pretty well, what else can we do this with, right? Are there any existing production systems that already unitize and maybe they don't do unique identification in the field? Well, maybe we can change that, right? And so what are the places where we can find similarities, patterns, practices that we can move towards this traceability paradigm and hopefully kind of create the same level of value that we've been able to do this with cotton. And so With that, I'll be happy to take any questions or any conversation that you have. I have to recognize my colleague Max Hooks, who's been indispensable in this, and that's me. So if you have any questions and want to email, feel free to do that. Depending on time, I've got some more fields I can show you, but it's all the same thing that we've really talked about already. So with that, I'll turn it back over to you.